So as we can see from the notes above, we have two types of collisions that we can deal with, elastic and inelastic. An inelastic collision is any collision in which kinetic energy is not conserved. In real life, we would consider these types of collisions collisions where the atoms stick together. So two football players coming together, two cars crashing, things like that. Elastic collisions have kinetic energy conserved. These would be things like two bouncy balls hitting each other. Now, in reality, there is no such thing as a perfectly elastic collision. Everything has some degree of energy loss, and that would be energy conversion to heat, light, sound, and things like that. But we're going to treat this as the pseudo-reality that we always treat physics, and deal with it in the best case that we can. So in each of these examples, it's usually better to deal with question B before we deal with question A. We have a 40,000 kg rail car traveling at 2.5 meters per second, colliding with a stationary 30,000 kg rail car. What is the speed of the cars if they remain locked together? Well, this leads into question B. Is the collision elastic or inelastic? It is most definitely inelastic because the train cars stick together. That allows us to go back and do question A and know which formula we should be using. Because it's inelastic, kinetic energy is not conserved, but momentum always is. So no matter what, we can always use the momentum conservation equation, which is m1 v1 plus m2 v2 equals m1 plus m2 v prime. All we need to determine here is which object will be object 1, which one will be object 2. So if we say m1 will be the 40,000 kg rail car, that would mean that v1 is 2.5 meters per second. That collides with a stationary 30,000 kg car, so m2 would be 30,000 kgs. v2, because this car is stationary, 0 meters per second. The only other variable we have in this equation is v prime, which is the combined velocity of the two objects as they stick together, and we don't know that. We're trying to find that. Go ahead and substitute in m1 40,000, v1 2.5, m2 is 30,000, v2 is 0, m1 again 40,000, m2 again 30,000, and v prime is what we're trying to solve for. Work out the math. 40,000 times 2.5 is 100,000. 30,000 times 0 is 0. So the left we will get 100,000 equals, and we can simplify in the brackets on the right, we will get 70,000 v prime divide both sides by 70,000. And because the masses of the rail cars were given to 1 sig fig, we'll continue to do that here. So divide that out, and to 1 sig fig, we get that the velocity is 1 meter per second.